Hello everybody. In this video I'm going to be talking about the lies with probability, and this is because I never knew this, but when you roll two dice, there is a probability that more often than not it will land on 7. And for me this is weird because typically, and I guess I've been living naive all this time, it's weird because I used to think that the roll of a dice is completely like, basically chance. It's not written, it's not pre written. And I mean, if we talk about one die, then yeah, it's unpredictable. Basically, it's unforeseen. You can't basically like tell what it's going to be, right? But if you roll two dice, you can do a probability tree. And I didn't know that, but I mean, it's basically like, like when you have like the flip of a coin, or what are the probabilities of like this or that happening, right? You have two dice with six sides, so then you just have to multiply 6 by 6, 6 times 6, and it's going to give you 36 possibilities. Right now, within those 36 possibilities, six of them, which is the highest form of combinations available for that number, which is a 7, is basically the one that's given, right, for the 7. So lucky 7, the idea of a lucky 7 is not really so lucky because it's based on probability. And this goes back to the video I made talking about this probability and potentials. And I mentioned in that video how the when you're picking out cards in a deck, right? Let's say you're playing a game and you need a 7 or you need a 6 or whatever, 6 of hearts, and you're picking out all these like numbers, right? You're picking out all these cards, and eventually you get the card you want, or you don't get the card you want. But it's not really that it's unpredictable, because as I mentioned, like there's already an order in the deck of cards that were shuffled prior to the game. And in that case, it's already written, you just haven't seen it, right? And I also spoke about the trajectory of a die, right? Or the dice when they're like in the middle of like suspended in the middle of the air, and when they land, there's a predictability in the pattern. We just can't calculate it because it's too complex, right? But I mean, it's written in that case. And I spoke on these two ideas, but I didn't know this idea also of, how basically there's a probability. I found it to be like completely weird, because then it's like if you play, like the game Catan, if you play Catan, which actually is a game you play with two dice, then you're going to want to put your pieces, in sevens, like close to the sevens or the sixes or the eights, and it's actually like a pyramid. I'm going to show a video. I'm going to show an image, sorry, here in this video of the pyramids and the different outcomes. So for 7, you have the probability of rolling a 1 and a 7, a 2 and a 5, a 3 and a 4, and then backwards, either instead of a 1 and a 7, a 7 and a 1, instead of a 2 and a 5, a 5 and a 2, and instead of a 3 and a 4, a 4 and a 3. And you basically see this with how this goes, how this happens with the rest of them. It's kind of like a pyramid, and at the extremes or at the ends, the probability of rolling, for example, a 2 or a 12 are both 1 in 36. So they actually have the lowest probability, right? Because the only thing you can get for a 2 is a 1 and a 1, right? And backwards. So I mean, you could really say it's like 2 out of 36, and for a 12 it's a 6 and a 6, or a 6 and a 6, right? So I guess it would be 1 out of 36 or 2 out of 36, but it's very low, right? So basically with this picture you see that it's kind of like a pyramid. Right now, this immediately made me think of the bell curve, or it's also called the normal distribution, where they basically say And I asked ChatGPT about this, and it said, no, it's not the same thing. And I understand why, but I'm still bringing the idea of the bell curve or the normal distribution in this. Um, ChatGPT said it's not the same thing because in terms of probability of rolling two dice, you have a very fixed set. You have it like like a pyramid. There are six possibilities, and that's it. The bell curve or the normal distribution, which basically starts like at the bottom, and as it works its way into the middle, it goes up top, and then it comes back down as it works its way down to the other extreme. Um, Actually doesn't touch zero ever on both sides. Like I guess it goes outward infinitely. And I remember where I saw this, the bell curve idea, which is like, for example, when you're trying to measure intelligences, like with IQ tests, so the average person is averagely smart, right? So this means that they're neither smart nor not smart. They're right in the middle, right? They're average. Um, I was remembering this funny joke from Peep Show where they said, most people aren't average or something like that, which was a play on words because most people are average, right? Most of us are in that middle, right? And that's the majority of us. The two extremes, which are like maybe the people that are not intelligent, that have low IQ, like probably below what, 90, 80, and the people that have a very high IQ, like the people above 110, 120, are not that many. So both extremes are low, and the average is always very high because it's the average. It's where most people are. It's where the mean, the medium, and the other the medium, the mean, and the average. I think, or yeah. Let me know in the comments what those three ones are. But it's where those three ones are met, right? With a little bit of varying degree from the mean, from the medium, from the mode. Yeah, the mode. Um, but they're all there, right? In that like center. So this doesn't really add up with the probability, but it is kind of like a bell curve, except in this case it's more of a pyramid. Um, but as you can see, like the, the chances are always in the middle. You can kind of work that into any theory or any game or any human life experience, right? Especially when betting, you may want to bet on what's in the middle, what's safest, because the extremes are always unlikely, right? Like if you're born, you're it's unlikely that you'll be really intelligent or really not intelligent or really dumb, right? The 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 likelihood of you being in the middle of being of average intelligence is really high, right? Because most people were there, were in the average IQ, right? And this can be applied to many different areas, right? Just take a look at other situations, and of course, this is for like graphs and things like that. So other areas where this well, I could get into that, into the idea of the bell curve later on, because I did have like other examples. I didn't include them here, but ChatGPT did give me other examples. But going back to this, the lies with probability idea, you also see this with, I want to like sneeze. You also see this with like roulette wheels, where they say that you have like, I don't know if you've ever seen like spin the roulette and you have like zero and then another one that has a double zero, and it actually says that that is a way for the house to have more chances of coming out on top and of the player not winning, because it's reducing your probability, right? Lottery games and specific patterns, in this case with lottery games, it's very unlikely that you'll get the same sequence of numbers, right, in that order. I don't really know how that works, but that's another way in which like the game is rigged, sort of thing. Card games and shuffle decks, when the cards are dealt. So in a game, sorry, in a card game, when you're dealing cards, um, you know, as soon as you already know the ones that are coming out, like let's say you have a hearts of kings, right? A king of hearts, and then you have another king of spades, right? You already know that those are no longer in the deck because they're already out. So this is like a way of counting cards to figure out like which ones are still in the deck, because you already know which ones are out of the deck, right? That sort of idea too. Um, stock market predictions based on situations, news, life circumstances. So the stock market can also be predicted, right, based on what's going on with the environment. And I was like, what about flipping a coin? And I asked ChatGPT about this, and it said, yeah, flipping a coin is always going to be, 50-50, I guess. So that unless like the coin is loaded, right, kind of like you would have a loaded die, so it always lands on a specific side. Um, but then I was like, how come we have this idea of like, if I were to tell you like, show me a picture of like risk, right? Like I just did recently for one of my videos, and you would probably have like two dice rolling in the air, right? Like all risk, chance, opportunity, unpredictability, chaos theory, right? But it's really not, because you can it's just that we don't have the capacity yet to predict the patterns, but it really is predictable, right? It can be predicted if you can factor in all of the different circumstances and variables. um, I guess if you roll a one-sided a one die, then it would be like more unpredictable. But basically, casinos lie about this to promote the idea of pure probability, to create suspense and encourage betting, but the odds are stacked, right? Basically, this is the conclusive remarks. So, are there real probabilities? Probably not. But we can still stick with the flipping of a coin or rolling of a die. But I just thought I'd share this with you guys, because for me, this was like, like, it caught me off surprise. It caught me off guard, because I didn't know that there was like something that you could do with the dice, like for there to be like the likelihood to increase. And in this case, it's with the seven. So I was like, what? That's weird. And as far as the bell curve or the normal distributions, I kind of want to look that up right now, so I get that out of the way. So let me look that up as bell curve examples. I know it's done with IQ tests. What is a real life example? A solid bell-shaped curve example is the roll of two dice. The distribution is centered. Yeah, see so ChatGPT is sometimes wrong. I know it happens with what is this called? I know it happens with IQ tests, right? Like as I just mentioned. But let me just look this up real quick for you all, so I can finish the video with this information. No, it's not gonna let me. See, I had the example, but I didn't. Give me examples of bell curve or normal distribution. All right. Heights of people, okay. Test scores like SATs, IQ tests, body weight, human error, repetitive tasks. That one's interesting. Repetitive tasks, the frequency of errors usually follows a normal distribution, with most errors being minor and fewer being extreme. So fewer errors are on the extremes, and most errors are minor. So fewer mistakes that are extremes, being extreme, are on the extremes, and the majority of minor mistakes are in the middle. Daily temperature over a month or a year, daily temperatures often form a bell curve clustering around the average for the season. Employee performance, blood pressure, measurement errors, shoe sizes, and income distribution. So there you go. I think that's an interesting thing to know also, that if you are betting, the odds can be in your favor in the average, right? So yeah, that's all I got for this video. I hope you guys enjoyed it, and I'll see you in the next one. All right, peace.